We have just received fresh data over the last few days as of January 25th, 2026, that drastically alters the trajectory of our investigation. The last 72 hours have not simply added a footnote to the observations of 3I Atlas. They have effectively rewritten the introduction to every model we were building. The drama peaked on January 22nd during a rare and critical alignment that many of us have been waiting for with bated breath. We witnessed a razor-thin phase angle of under 1 degree between the Sun, the Earth, and the comet. This geometry created the conditions for a perfect opposition surge, a phenomenon where the object is bathed in full, direct illumination, appearing to us as a sudden dramatic spike in brightness. While ground-based telescopes struggled with the glare, we now have confirmation that the Hubble Space Telescope successfully capitalized on this fleeting window. The Space Observatory snatched 6 distinct glimpses, each lasting 170 seconds, spanning a tight observational window from 1310 and 30 seconds to 1343 and 33 seconds universal time. The data flowing down from these exposures is, frankly, startling. What was previously a fuzzy point of light has resolved into a complex system of emissions that defies standard cometary behavior. Hubble has unveiled a halo stretching an incredible 100,000 kilometers sunward. To put that into perspective, you could string 10 Earths end to end, and they would barely span the width of this gaseous shroud. This isn't just a dusty envelope. It is a scream of activity from an object that should be quieting down as it recedes 7 astronomical units from the Sun. Instead of fading obediently into the dark, the object has utilized this opposition surge to reveal observations that we are only just beginning to decode. The sheer scale of this sunward halo suggests an energetic release of material that is consistent and voluminous, unrelated to a simple passive sublimation process driven by the weak solar heating at this distance. We are seeing a brightness spike that is tied directly to the backscattering properties of the material in the coma. This is the crucial piece of the puzzle we needed. If you are following this investigation closely and want to ensure you get the alerts the moment we process the next batch of telemetry, make sure you are subscribed to the feed right now, because the data we are seeing from January 25th is moving faster than the official press releases can keep up with. Returning to the Hubble imagery, the analysis of this 100,000 kilometer structure indicates it is not merely a diffuse cloud. It has structure. Through the specific viewing angle provided by the opposition surge, the light curve behavior tells us about the particle size and density. If this were a typical fluffy comet shedding primordial dust, we would expect a very specific photometric signature, a coherent brightening consistent with porous aggregates. We are not seeing that. We are seeing a sharpness to the surge that implies something else, perhaps compact icy shards, or, as some of the more daring theoretical models suggest, a surface that is more reflective and solid than a dirty snowball has any right to be. The timing of this surge on January 22nd was absolute perfection. It acted like a relentless spotlight, stripping away the shadows that usually hide the topography of the nucleus. While we cannot resolve the surface directly even with Hubble, the shape of the halo acted as a proxy map for the activity on the surface. We are looking at a coma that is carbon dioxide dominant, yet it is observing this immense sunward expansion. This contradicts the expected lethargy of a comet moving this far past the frost line. Usually, water ice locks up and activity plummets. But here, the activity is expanding, creating a localized atmosphere that is larger than some planets. The significance of the January 22nd viewing geometry cannot be overstated. By observing the object at a phase angle of virtually zero, we eliminated the shadows cast by the dust particles themselves on one another. This coherent backscattering effect is what gave us that sudden magnitude spike, but it is the quality of that spike that matters. The intensity suggests the particles are not just interacting with sunlight, they might be aligned. The data implies a uniformity in the outflow that challenges the concept of chaotic, random eruptions from a heated surface. We are looking at sustained, powerful pressure driving this material out against the solar wind, maintaining that 100,000-kilometer structure in defiance of the dissipating solar energy. As we parse through the January 25th observational reports, the consensus is shifting away from a simple, passive rock. The energy required to maintain such a halo at 7 astronomical units is formidable. We are crunching the numbers on the sublimation rates of carbon dioxide and carbon monoxide, and while they can explain some of the activity, the architecture of this halo, the way it holds its shape, is the real anomaly. It is almost as if the coma is a shield, a persistent barrier generated by the nucleus. And this shield is not amorphous, it is directional. The sunward extension is particularly baffling because the solar wind should be sweeping this material back into a tail. Instead, it pushes forward, upstream against the flow of the star before curling back. This requires a specific ejection velocity and particle mass that we rarely see in such perfectly sustained equilibrium. What we are witnessing in this fresh dataset is the aftermath of a heat pulse, likely triggered during the solar rendezvous back in October, but the endurance of the reaction is what separates this from a typical outburst. A normal comet burps and settles. 3I Atlas is roaring. The opposition surge was our flash photography moment, and the picture it took shows a giant, glowing anomaly hanging in the dark, refusing to go silently into the night. This is the baseline we are working from as we move into the structural analysis. The sheer brightness and the extent of the halo were just the opening act. The real shock came when we applied the filters to look inside that glare. That is where the geometry stops being just a cloud and starts looking like a blueprint. This brings us to the specific structures concealed within that halo, distinct features that have just been resolved and are fueling an intense debate about symmetry and design. As we peel back the layers of the January 22nd opposition surge, the story transforms from one of sheer brightness to one of startling geometry. Once the glare of the halo was mathematically dampened using the Larson-Sekanina filter processing technique, the chaotic cloud vanished and a distinct, organized structure emerged. The symmetry here is the headline. The 3 mini-jets are spaced with near-perfect 120-degree separation. In nature, we expect randomness, chaos, and jagged edges. Nature makes mountains and coastlines. It rarely draws equilateral triangles in the vacuum of space with jets of gas. One of these jets appears mysteriously dimmed by our current vantage point. But the triangulation of the active vents suggests a distribution of surface activity that is equidistant and balanced. This begs the question that is currently setting the astrophysics forums on fire. Is this a 1 in a billion natural fluke, or are we looking at deliberate design? The antitail itself is a paramount anomaly. Typically, an antitail is an optical illusion, a projection effect where heavy dust particles left in the comet's orbit appear to point sunward when Earth crosses the orbital plane. But this feature is persistent. It is piercing through the solar gales and cosmic rays, defying deflection over hundreds of thousands of kilometers. For a stream of particles to push upstream against the solar wind requires significant mass or significant velocity. The theories emerging this morning are wild but necessary. Are we looking at dense ice shards, heavy clumps of metallic dust, or, as the more exotic theories propose, are these massive constructs or exhaust plumes maintaining a trajectory? The behavior of these jets is further complicated by the fresh data on the object's rotation. Dissections of the light curve from January 25th reveal a rhythmic 7.2-hour wobble. This is not a clean, gyroscopic spin. The object is jiggling. The jets are oscillating by plus or minus 20 degrees, dodging perfect alignment with every rotation. This wobble suggests a non-principal axis of rotation, meaning the object is tumbling. Yet, despite this chaotic motion, the jets maintain their 120-degree relative structure. It is like watching a spinning top that is off balance, yet the paint stripes on it remain perfectly equidistant. This spin axis is eerily locked within 8 to 20 degrees of the Sun. Statistically, for a random tumbling object to maintain its pole pointing so close to the Sun is an odds-defying scenario, calculated at billions to 1 against chance. A natural object, buffeted by outgassing and gravitational tides, should have a random spin vector. For it to keep its eye or its nozzle-pointed soleward while tumbling implies an active feedback loop, or a moment of inertia that is incredibly specific. This alignment is what allows the antitail to persist in its sunward orientation, creating that defiant spike we see in the Hubble images. We are currently tracking a staggering 18 separate anomalies associated with this object. We have the wild nickel-iron imbalances detected in the spectrum, a carbon dioxide saturated shroud, and now this distinct geometric jet structure. Each one of these could be explained away individually as a freak occurrence. But when you stack 18 anomalies on top of one another, the coincidence explanation begins to crumble under its own weight. Standard cometary models are breaking. They cannot account for a tumbling object that maintains stable symmetric jets and a sun-locked pole. The three mini-jets evoke whispers of technological fingerprints. If you were designing a probe to stabilize itself or maneuver, a tripartite thruster arrangement is a logical engineering choice. It provides vector control across multiple axes. The fact that these jets are emerging now, after the perihelion, could be interpreted as a system coming online, or venting heat after the close solar pass. The 7.2-hour rhythm acts like a heartbeat, a predictable cycle that governs the pulses of activity we are measuring. However, we must remain grounded in the physics. It is possible, though increasingly difficult to model, that the shape of the nucleus itself, perhaps flattened or bilobed, is funneling the sublimation into these distinct vents. If the object is shaped like a flattened disk, as was theorized for Oumuamua, then the heating would naturally concentrate on the rim or specific faces, potentially creating this symmetric outflow. But the anti-tail remains the stubborn outlier. For dust to hang there, motionless against the pressure of sunlight, it must be made of large, heavy grains, vastly different from the smoky, micron-sized dust of typical comets. We are seeing a dynamic system. The January 25th updates show that the wobble is influencing the jet intensity. As the object tips by those 20 degrees, the jets flare and dim in cadence. This breathing pattern gives the impression of a living mechanism reacting to its orientation. The natural facade is being subjected to the most intense scrutiny in history, and with every hour of data, the picture gets more complex, not simpler. We have moved from looking at a bright dot to watching a tumbling, symmetric, jet-spewing engine moving through the outer solar system. And as puzzling as the movement is, the stuff coming out of those jets is even more baffling. We need to talk about the chemistry because the molecules being detected in that halo are telling a story that is just as alien as the geometry. The geometry of 3I Atlas is strange, but its chemical payload is rewriting the textbooks on interstellar chemistry. As of this morning, January 25th, the spectroscopic analysis of that glowing halo and those symmetric jets has confirmed a composition that is starkly at odds with our local cometary population. We are seeing ices, water, carbon dioxide, carbon monoxide, nitrides, and hydrocarbons sublimating in a frenzied outburst. But the ratios are the smoking gun. This is a carbon dioxide dominant coma, boasting an 8-to-1 ratio of carbon dioxide to water. In our solar system, comets are typically dirty snowballs where water is the primary volatile. To see carbon dioxide outpacing water by such a massive margin is rare. It suggests an origin in a star system with a vastly different chemical inventory, or perhaps a formation history in a region of space cold enough to freeze carbon dioxide solid but devoid of the water abundance we take for granted. This high concentration of supervolatiles is what drives the explosive activity we are witnessing at 7 astronomical units. Carbon dioxide turns to gas at much lower temperatures than water. It is the propellant driving the jets and the anti-tail. But the plot thickens with the detection of organic compounds and elusive carbon nitriles once locked away in the nucleus. These are the building blocks of amino acids, the prebiotic chemistry that underpins life as we know it. The outburst triggered by the solar passage has cracked open the surface, unleashing these complex molecules into the void. We are detecting signatures. Some researchers are looking at this carbon-rich shroud and asking if it could be a mask. There is a hypothesis floating around the community that a massive engineered core could be hidden beneath a layer of natural insulation. If you wanted to send a probe across the galaxy, coating it in a thick layer of ice and organics is a brilliant way to protect it from cosmic radiation and micrometeoroids. It is the ultimate camouflage. As the object heats up and sublimates, it sheds this natural skin. The 8-to-1 carbon dioxide ratio could be the signature of that ablative shield burning off. It is a controversial idea, certainly, but we have to follow the data where it leads. The water evaporation rate has spiked 20-fold, yet it still lags behind the carbon dioxide. This differential sublimation is sculpting the uneven dust shroud we discussed earlier. The fact that we are seeing nitrides, compounds containing nitrogen, adds another layer of intrigue. Nitrogen ice is incredibly volatile. For it to survive the journey between stars, it must have been buried deep or locked within a crystal lattice of other ices. Its release now signals that the object is turning inside out, thermally speaking. This chemical profile is what fuels the litmus test discussion. If the dust and gas are fluffy primitives, remnants of a protoplanetary disk, they should have a specific fractal structure and density. If they are refined relics, the debris of a technological civilization or a processed shell, the isotopic ratios and the grain density will look different. We are on the razor's edge of that distinction right now. I want to pause here and ask you, what is your gut telling you? Do you think this chemistry is the signature of a strange alien geology, or does the ablative shield theory hold water for you? Drop a comment below with natural or construct and tell me why. I'm reading through them as the new reports come in. The January 25th update also highlights a wild nickel-iron imbalance. Metal abundances in cometary atmospheres are typically low and balanced. To see spikes in nickel and iron suggests that we are either seeing a very metallic asteroid disguised as a comet, or we are seeing the exposure of a metallic core. If the ice is just a wrapper, we might be catching our first spectral glimpses of the hull beneath. This connects back to the anti-tail. Heavy metallic dust would explain the resistance to solar pressure much better than fluffy carbon grains. We are also seeing swirling molecular bursts. This isn't a steady stream, it is pulsing. The chemical composition varies with the wobble we described in the last chapter. This implies the surface is heterogeneous, patchy. One side might be rich in carbon dioxide ice, another in organic sludge, another in exposed rock or metal. As it tumbles, it sprays these different flavors into space, creating a spiraling chemical signal that we are trying to decode. NASA is currently maintaining the stance that this is a quirky interstellar orphan, devoid of techno-signatures. They argue that the organic bounty is typical of the chemistry found in cold molecular clouds. And they are right, to a degree. Space is full of organics, but the specific combination, the CO2 dominance, the nitrogen release, the coherence of the jets, and the metal imbalance creates a profile that strains the orphan rock narrative. Their own January 25th YouTube release admitted the organic bounty was a bombshell. They are validating the strangeness while stopping short of the A word. This chemical analysis is the foundation upon which the observation campaign is built. We aren't just taking pictures anymore. We are sniffing the air around this thing. And to do that effectively, we need more than just Hubble. We need the entire electromagnetic spectrum. That is exactly what is happening right now as a fleet of space telescopes hijacks their own schedules to stare at this one point in the sky. The multispectral siege has begun, and the target is the dust. The urgency of these chemical and geometric anomalies has triggered a virtually unprecedented coordinated response from the world's leading space agencies. As of January 25th, we are witnessing a multispectral siege of 3I Atlas. The Transiting Exoplanet Survey Satellite, or TESS, which is designed to stare at stars for weeks on end to find planets, has hijacked its own exoplanet Vigil. Instead of hunting for new worlds, TESS is now dedicated to live brightness feeds of the comet. This is critical because TESS provides a continuous stream of data, allowing us to track those 7.2-hour wobbles and the jet outbursts in real time, filling in the gaps between the high-resolution snapshots from other observatories. But TESS is just one player in this orchestra. It is syncing its observations with a heavyweight lineup: Hubble, Europa Clipper, JUICE, X-RISM, and XMM Newton. This is a calibration limbo, a moment where mission controllers are pushing their instruments to the limit, often outside their primary mission parameters. The European Space Agency's JUICE and NASA's Europa Clipper are en route to the Jovian system, but they are turning their sensors back toward the inner solar system, relatively speaking, to catch this traveler. The inclusion of X-RISM and XMM Newton is particularly telling. These are X-ray observatories. Comets do emit X-rays, usually when the solar wind slams into the cometary atmosphere, a process called charge exchange. But dedicating these pioneering high-energy instruments to 3I Atlas suggests the scientists are looking for high-energy phenomena that standard sublimation cannot explain. Are they looking for magnetic field interactions? Are they hunting for the spectral lines of exotic heavy metals in the coma that only X-rays can reveal? The X-ray flares being monitored could be the smoking gun for a magnetic anomaly associated with the object, something a ball of dirty ice shouldn't possess. The ultraviolet capabilities involved here are poised to unmask the true nature of the dust. This is the litmus test we alluded to. Ultraviolet light interacts with small particles in a very specific way. By measuring how the comet scatters UV light, researchers can determine the porosity and composition of the dust grains. Are they fluffy primitives, fractal aggregates of dust that grew gently in a nebula? Or are they refined relics, dense, processed materials that don't fit the natural formation models? The January 25th updates mention pioneering X-ray flares and UV data that are currently being calibrated to answer this exact question. The phrase ice volcanoes has started circulating in the reports from January 24th and 25th. This refers to the surprise eruptions of volatiles we discussed, but in the context of the observation campaign, it represents a target. The observatories are trying to catch an eruption in the act across all wavelengths simultaneously. If TESS sees a brightness spike, Hubble sees a jet form, and XMM Newton detects an X-ray flare all at the same second, we can triangulate the physics of the mechanism. This level of scrutiny is usually reserved for supernovae or black holes, not a fading comet. It betrays a deep-seated anxiety, or perhaps excitement, within the scientific community that mundane physics might not prevail. The term alternative scenarios is appearing in the technical briefings, a polite scientific euphemism for the ideas championed by Avi Loeb and others. They are essentially stress testing the natural hypothesis. Every instrument pointed at 3I Atlas is looking for the crack in the facade, the data point that refuses to fit the curve. We are also hearing about uncomfortable doubts seeding the discourse. The sheer number of anomalies, 18 and counting, is making it difficult to construct a coherent natural history for this object. The idea that these wanderers swarm the galaxy, laden with extraterrestrial clues or bizarre makeups, is shifting from science fiction to a serious astrobiological consideration. Could they ferry life? The organic bounty says yes. Could they ferry tech? The geometric jets and spin stabilization suggest it's non-zero. Could they ferry threats? That is the question looming over the planetary defense offices, though this specific object is on its way out. The January 25th Indy probes of the January 21st shots are also adding to the noise. Amateur astronomers and independent researchers are processing the raw data faster than the agencies, questioning if those structures pulse with intent. The X chatter, formerly Twitter, is erupting with amateur snaps showing the jets in snowflake splendor, a poetic description for that symmetric nozzle pattern. Tails are being described as snaking 15,500 miles, like thrusters firing. This frenzy is not just idle speculation. It is driving the scientific focus. The professional observatories are being directed to look at features first flagged by the citizen scientist army. It is a feedback loop of discovery, and all of this multispectral data is converging on one final critical date. The object is moving away, but it has one last appointment with the king of the solar system. The data we are gathering now is the preparation for the end game, a gravitational encounter that will either fling this object into the abyss or reveal its final secret. We need to talk about Jupiter. The final act of this interstellar drama is set for March 16, 2026. While 3I Atlas is currently receding, it is heading toward a nail-biting rendezvous with Jupiter. The trajectory calculations show the object will skirt the gas giant's gravitational grasp at a distance of 0.36 astronomical units. This is a close shave in cosmic terms, a gravitational tango that will alter the object's path outbound. But the lead-up to this event, specifically the January 24th graze at 290 million kilometers, has already delivered a gravitational whisper, a measurable tug that helps us constrain the object's mass. The serendipity of this encounter is staggering. The odds of an interstellar object entering our system and passing this close to Jupiter are calculated at 1 in 25,000. It borders on the suspicious. Jupiter is the vacuum cleaner of the solar system, sure, but for a visitor to thread the needle like this invites the probe speculation again. If you were a scout entering a system, using the largest planet for a gravity assist or a braking maneuver is standard operating procedure in orbital mechanics. The fact that 3I Atlas is executing this maneuver has fueled the "what if it's alive" frenzy. Avi Loeb's recent media missive crowns the mini-jets as an anomaly supreme in this context. He vows that the juiciest truths await us before that March 16th date. The proximity to Jupiter will exert tidal forces on the comet. If the nucleus is a loose pile of rubble, Jupiter's gravity might pull it apart, revealing its internal structure. If it is a solid, engineered monolith, it will resist those tides rigidly. The way the object deforms or fails to deform during this flyby will be the ultimate material stress test. We are watching a celestial experiment in real time. The gravity assist it receives will change its velocity and vector. By precisely tracking this change, we can weigh the object with extreme precision. If the mass is much lower than its visual size suggests, it implies a hollow structure or extremely porous material. an aerogel or a shell. If it is denser, it implies heavy metals. This interaction is our last shot to pierce the veil before it slips into eternal night. After March, 3I Atlas will accelerate into the outer dark, fading beyond the reach of even our most powerful telescopes. It will carry its secrets of chemistry, of origins, or of intelligences beyond back into the galaxy. The cosmic drifter versus probe scouting our system debate may never be fully resolved, but the data collected in these final weeks will be the legacy we study for decades. The January 25th revelations of the 7.2-hour wobble, the 120-degree jet symmetry, and the massive opposition surge have given us more questions than answers. But they have undeniably proven one thing. We do not understand the universe as well as we thought we did. This object has challenged every textbook model. It has forced us to hijack our best observatories. It has united professional astronomers and internet sleuths in a shared mystery. Whether it is a natural fluke or a deliberate visitor, 3I Atlas has changed us. It has shown us that the void is not empty. It is full of active, dynamic, and potentially intelligent potential. We will be covering the Jupiter approach in exhaustive detail as the telemetry comes in. The story isn't over. The climax is just weeks away. If you value this kind of deep, data-driven analysis that respects your intelligence and refuses to gloss over the hard questions, please hit that like button. It helps the algorithm signal that there is a demand for real science news. Keep looking up and stay curious. The universe is speaking. We just need to learn how to listen.